In China there is a very special fighter, that is the J16D. Its airframe platform is the J16, so it is actually a fourth-generation aircraft. But this fourth-generation aircraft has to catch up with the cost of the J20, almost the highest cost of China's current service aircraft. So how strong is the J16D? Why is it so expensive for the PLA to service it? To understand the value of this air electromagnetic blade, we need to analyze it from three dimensions: historical lessons, technological evolution, and the shape of modern warfare. In fact, as to why China has to serve J16D fighters, an actual case can be illustrated. 1994, a U.S. Kitty Hawk class aircraft carrier directly entered Chinese territorial waters and tracked and blocked a Chinese nuclear submarine. The Chinese and American warships faced each other for about 72 hours, and the Chinese nuclear submarine was pinned down for about 72 hours. From this incident, it is clear that electronic warplanes play a huge role on the battlefield. This incident was like a hammer blow that made the Chinese military deeply realize that modern warfare has shifted from the collision of steel torrents to the competition for the electromagnetic spectrum. Since then, China has developed a series of electronic reconnaissance aircraft Yun-8 GX-055 type destroyer shipboard electronic warfare systems and other equipment, but there is always a lack of tactical level electronic warfare, with the US military A-18G Growler counterweight. The emergence of J16D is the ultimate answer to fill this strategic gap. Traditional electronic warfare equipment: there is an obvious mobility paradox. Land-based systems are powerful but difficult to maneuver. The Navy's electronic warfare ship speed is insufficient. Transport 9 and other medium-sized transport aircraft converted electronic warfare aircraft. Although the range is far, but the lack of surprise ability. J16D innovatively solved this problem through the fighter platform. Its maximum flight speed of Mach 2.5 exceeds that of all current electronic warfare aircraft. Combat radius of 1,500 kilometers. Can cover the key strategic directions. With the air refueling can be implemented across the theater of operations maneuver. This maneuver advantage in the South China Sea and other hotspot areas have special value. When the early warning aircraft found the enemy ship formation to start radar, J16D can fly from the front-line airports in Fujian to the Bashi Channel in 30 minutes, while under the same circumstances, the Transport-9 electronic warfare aircraft need 90 minutes, surface ships need hours. In the fast-changing modern battlefield, this rapid response capability often determines the ownership of the electromagnetic spectrum control. As China's first dedicated tactical electronic warfare aircraft, the J16D achieves technological leapfrogging in a number of areas. Its airborne electronic warfare system adopts a modular design, with 6 heavy-duty mounting points to carry electronic jamming pods of different frequency bands, covering the radar spectrum from L-band to Q-band. Each pod integrates 128 active phased array units, which can simultaneously implement precise directional jamming and wide-area suppression jamming. Compared with the LQ-99 tactical jamming system of the US EA-18G, the J16D's digital jamming effectiveness has been increased by 3 times, and its response speed has been shortened to nanoseconds. What is more noteworthy is its combat concept of combining soft and hard. In addition to electronic jamming equipment, J16D retains 4 weapon mounting points, which can mount hard kill weapons such as Hawk 91 anti-radiation missiles and LD-10 anti-radiation drones. This design breaks the limitation of traditional electronic warfare aircraft of only jamming but not attacking, and forms a complete killing chain from electromagnetic suppression to physical destruction. In the simulated confrontation, J16D has successfully guided anti-radiation missiles to hit the shipboard radar target 400 kilometers away in the complex electromagnetic environment. The value of the J16D lies not only in the performance of a single aircraft, but also in its pivotal role in reshaping the air warfare system. When cooperating with J20 stealth fighters, the former can use electromagnetic cover to break through the enemy's air defense network, while the latter relies on stealth characteristics to carry out precision strikes. This combination of electromagnetic fog plus stealth blade has been seen in the tactical demonstration at the Zhuhai Airshow 2022. J16D first paralyzes the early warning radar of the Blue Army, then J20 uses electromagnetic silence to break into the defense line, and finally the unmanned aerial vehicle group guided by J16D completes the target confirmation and battle damage assessment. This kind of multi-dimensional synergy has shown its power in the control of the East China Sea Air Defense Identification Zone. When a foreign electronic reconnaissance aircraft approaches, the J16D can move forward to implement electromagnetic countermeasures, and its J800 electronic countermeasures system can effectively suppress advanced airborne radars such as the APG-79 over 82.2023 during an interception operation in August. Two J16Ds, by means of cross-jamming tactics, caused the radar display of a certain foreign AWACS early warning aircraft to show a 12-minute-long snowflake jamming, forcing it to abort its reconnaissance mission. They were forced to suspend the reconnaissance mission. The high cost of the J16D is often discussed, but if you put it into a systemic operational perspective, the investment is more than worth it. One J16D's electromagnetic suppression range can be up to 100,000 square kilometers, which is equivalent to the coverage area of 5 land-based electronic warfare battalions. Deploying 6 J16Ds in the South China Sea will build an electromagnetic barrier covering the entire strait. In contrast, the construction of a land-based facility of the same effectiveness would require a fixed investment of more than $3 billion, and has the weakness of being vulnerable in wartime. The deeper value lies in the traction effect of technology iteration. The third-generation airborne conformal antenna technology developed for the J16D has been transplanted into the electronic warfare system of the Type 055 destroyer. Its electromagnetic spectrum sensing algorithms are pushing the early warning radar to evolve towards cognitive electronic warfare. This development mode of a machine with a system makes J16D a key node in the transformation of the PLAS information technology. Looking back from the historical dimension, from the Yellow Sea to the electromagnetic battle, the J16D's installation marks the completion of the Chinese Army's leap from passive defense to active electromagnetic control. This warplane is not only a breakthrough in technology and equipment, but also a revolution in operational thinking. It signals that future wars will be won and lost in the invisible electromagnetic space, and China is building a new Great Wall on this invisible battlefield.